Good evening, ladies and gentlemen. I only have one message to you, and that is one that we want to reach out to you for the development and research of all kinds of healthcare and lifestyle devices. That's the short version. And since it's already well beyond 7 o'clock, I'll try to make this talk as easy to digest as possible. So let me start with a couple of observations. India is kind of a special place if you think about healthcare and lifestyle. First of all, I think this is a very particular one. Private spending is really dominant in the Indian healthcare markets. It's the only place on the planet where private spending is 2/3, and sometimes even more, 2/3 is coming from private. And that means, of course, you get a tremendous drive. You can move much faster, I believe, in India than in most other countries. Government regulations are not as strict, which is helping you to accelerate. Another one is a sheer need for solutions. There is definitely a lack or scarcity of both hospital beds and physicians, which is very outspoken here in India. So you need solutions to deal with this, and you have the drive of public spending behind it. So that is going to lead to solutions that you will not find anywhere else on the planet, I think, in the next years. Moreover, you have in India a middle class that is growing particularly fast. So there's very fast economic growth. And that means if you look at this, the middle class is growing, and that means the middle class in India will be consisting of more people than all of people in the US, and probably more than all of the people in the US, Europe, and even Japan combined. So that is tremendous buying power that's coming from there. And with that, unfortunately, you also start to see appearing the same type of diseases that we see in Europe and US, notably chronic degenerative disease, heart failures, and brain problems. So these you also see are very much on the rise in India. And what I think that will bring in India is the ascent of telemedicine. And I think there's two types of niche markets, or market niches, depending on how you look at it, based on these unmet needs. The first of all is the first-line care for people in rural areas. And this is really something that is going to be very particular in India, I think, where you have a large rural community and you don't have many physicians and hospital services there to service these people. That's one. The second, and there you will see some more competition, I think, with what you see in Europe and US in particular, is diagnostic tools for ambulatory monitoring of people in the urban middle class. So that's something that we definitely also see happening in Europe and US. Telemedicine, big thing, and it's happening right now in India. All kinds of things happening. This is a press release from the Apollo project. You also see quite a bit of drive from the Indian Space Agency there. So lots of things happening in the field of telemedicine, and I think for very good reasons. Typically, to go with all of these systems, you see some basic diagnostic equipment. So basic X-rays, telepathology systems, ECG systems, stethoscopes, and so on and so forth. What we can offer, and that's also my offer here to all of you in the audience, we can offer help to develop next generation ambulatory monitoring systems. And we've been working on that at IMEC for the past 10 years in the by now well-known and understood open innovation model. So we do all of these things, and I will show you just a couple of examples. We do all of this with our partners in the field. And the first one starts with a very simple concept of an ambulatory ECG system. So it's basically a necklace. I'm holding one here, so if you're interested, we also have some of these things at our booth that allow you to have monitoring of people, an ambulatory setting, doing one lead ECG, and because of the low power electronics that we put in there, we can do this monitoring continuously for about 7 days. Yeah. So we develop a technology that goes in there. We go into clinical studies to prove that these things are really working. This is just an example of an epilepsy study that we did in a lab in a hospital near to our site in the Netherlands, which is looking into epilepsy. So we've shown here that with this device on the arm, we were able to detect epilepsy in a number of patients, and we did a number of cases. In this case, we did about 50 patients. You see graphs of 3 patients. For 2, this seems to work. For a 3rd patient, in this case, we get quite some false positives. So it shows, like with any clinical solution, it works in certain cases, it does not in certain others. We do that, again, in partnerships with the companies, with the clinical centers that are behind us. Epilepsy is one application, but it's a cardiac monitor, so of course you can also use this for other situations, for instance, atrial fibrillation. So we did a test there with about 50 patients running through the German Heart Center, validating, again, these type of systems against what is used today as a golden reference. We've also looked into tailoring these devices. Notably, if you think about India, you're going to have different requirements from what you see, for instance, in Germany. So here's one example of a device, and we also have a device here on the booth. You can check it out later if you're interested. This is tailored to be more affordable. So it has some other design constraints in it. Has a bit smaller battery, and it also comes with a Bluetooth Low Energy radio. So this device is now also fully compatible with cell phones and computers. So you can hook this up and get for ECG data streaming to a computer. We also build in some of the things that we learned from a more complex examples. Give you an example, for instance, motion artifact reduction. If you go into ambulatory ECG, you need to be able to monitor cardiac function with a person that is moving around. So you need to do something in precautions to do that. That's all in there. It also has other features in there. Again, if you're interested, come and check it out at our booth. I want to switch gears now and move into another type of application, which is EEG, brain activity monitoring. And this is an example of the clinical practice today. This is the biggest hospital in Flanders. And this is a testimonial of a neurologist that we're working with. Well, let me just rephrase what he's saying. So he's...
if you do a normal EEG study in a hospital setting, you need trained personnel to do this. So it takes like 1 hour to put on the EEG machine. So you need trained professionals. It takes a long time, and it's not very pleasant for the child or for the patients to put all these electrodes on the head. The smaller and the less wires, the better, because this increases the space you can move in as a patient. So now they are stuck to a bed. They cannot run around. They have to stay in the chair or in the bed while we are measuring the brain activity. So if there would be a system without wires, quite small, and that you can put it on the head without any big problems, the child can run around in school or at home or even in the hospital, and you get a much more natural environment. You also see much more normal brain activity instead of being blocked to a chair or a hospital bed.
So that's the testimony of the neurologist. You saw the current clinical practice. Now just imagine they put all of these things on you, and then they're going to tell you, well, we're going to monitor you for a day, and if you're unfortunate, for a week, and you're tethered to the bed, and then they're going to tell you, just behave normal. That's going to be pretty hard So we started working on systems that can help in such situations. This is again one of the examples. Just like with the ECG, we developed this brain monitor to solve this unmet clinical need of having a high quality EEG system that can be used in the field and that indeed can allow these people to behave normally. And this is a short movie clip on the latest generation, which also has active electrodes in there.
There are three main reasons why we work with clinical centers and hospitals. The first one is to understand the problem that they currently have in their daily practice. For that, we need to talk to clinical experts, to doctors, to patients, also to nurses, to really understand what makes their life difficult today and how new technologies would help them in their daily practice. The second reason is more a benchmarking reason, a validation reason. So we want to be able to compare our new technologies with existing and demonstrate that even new technologies improve the life of patients. They are at least as good, if not better, in terms of outcome compared to existing equipment currently available in the hospitals. The third reason is about driving the research. We want to understand the challenges that people currently have and define new technologies based on that. This is about new sensors, this could be about new circuit, or new technologies that will improve and create the future of healthcare.
So in summary, so we've been able to build out also an ecosystem in this field. You see some of the names of the companies that we're working with today in this field. And as I said at my opening, today we also want to reach out to you to set up collaborations in these areas, in other areas. We've established also a team in India to fully support all of you with this. You can use the IMEC IP and know how to differentiate, to accelerate your time to market. And I hope to see many of you later during dinner while having a drink. Thank you very much.